Hello friends, welcome back to GetUp. My name is Vikas. In my previous video lecture on engineering mechanics, we have studied about moment of inertia and centroid, okay? And I hope you have practiced some questions on this concept of moment of inertia and centroid. And today we are going to study about friction, okay? Now friction is a word which is quite a common word that you have heard, okay? And this friction is used in day-to-day life, okay? And the live example of friction is that whenever you walk in, even if you are walking, okay, then you walk with the due to the force of the friction, okay. And when you are writing something on a paper, then also friction force is there. So for every process you do, there is some friction, okay. So what is the friction? Friction is a force which opposes the motion of an object over a surface, okay. Suppose that if you are moving on a surface, okay, then you experience some force, okay, feel some force, okay, due to which you are able to move, okay. Now suppose that if you are moving on a smooth surface, you will be moving very easily, okay. For example, you are moving on a plane, but suppose if you are climbing a mountain, okay, and that is also a rough terrain, okay, or you can say it is a rough surface, so you will find some difficulty in moving. So from this example, you have understood that there is some effect of irregularities or surface, or you can say surface in contact on the friction. So this force which acts due to contact of a surface over a surface is called force of friction. And as I have told you, when you are moving on a plane surface or climbing a mountain which is a rough surface, so that also means that whenever you are moving, the force that you experience in opposition to the movement is called as friction force, okay. Suppose that, let us see with the example. Suppose this is a person who is pushing this block over a inclined plane, okay. The person is pushing this weight, or you can say this block, okay, with this inclined plane. Now suppose that he is applying some force of 20 Newton, okay, and this block, he will try to push the block, okay. So when he will be pushing this block with this force, this block will not be moving. As soon as he will increase the force to 30 Newton, then to 50 Newton, after reaching a value of force, this block will start to move in this direction, okay. Now before this 50 Newton was achieved, okay, he applied this force of 50 Newton, this block was not moving. And the reason why it was not moving is a force which was opposing this movement, and this force was called force of friction, okay. Also we can say a ball rolling on the ground gradually slows down and come to rest due to force of friction between the ball and the surface, okay. Suppose that if you are playing cricket, or you can say playing a table tennis, okay, and suppose that you have hit a ball, okay, after some time, after hitting the ball will ultimately spin for some time, and then it will come to rest. The reason why it will come to rest, that is the force of friction between the surface and the ground, or between the ball and the ground. So that means there are some factors which are affecting this force of friction. The factor which are affecting the force of friction is the nature of the surface in the contact and how surface are pressed together, okay. Now suppose that there is this is a surface, and this is a roller, this is a bar which is rolling down this inclined plane and along this surface. Now this surface is a smooth surface, okay, and as you can see, this is a rough surface. So when this roller will move down this inclined plane and then will reach this surface, then it will reach it very quickly. And the reason is that there is the nature of surface in contact between this roller and this surface is a smooth surface, okay. So the surface irregularities are very less, okay, and since the surface irregularities are less, so this will find some ease of movement over this surface. But if it is a rough surface, or there are some irregularities over this rough surface, then this roller is moving from here, and this has reached only to this place, okay. But this, for the smooth surface, the roller has reached to this place. The reason is that this uneven surface or rough surface is, the friction is quite more here. So the force that this roller need to apply to move has been reduced due to this friction force, which is opposing this motion. Another example of this force of friction is this how surfaces are pressed together. So this also depends, force of friction also depends on this how surfaces are pressed together. If we try to press, we are walking and we are pressing our legs on this, or feet on the ground, okay, how hard we press the feet on the ground, we will impart more force and we will oppose the friction, and we can walk. So how do we used to walk on the ground? Like this. This is the way we used to walk on the ground, okay. So what we do, we are pressing from our feet on the ground, and we are applying more force onto the ground so that we can resist the force of friction which is acting between the ground and our feet, and we can walk. And this is how we used to walk. We used to press it hard on the surface, and we need to reduce the force of friction, and this is how we are able to walk on the ground. This is one of the example. Even if you are writing on a paper, if you are writing on a paper, suppose I am writing it with the help of a pen, okay, so I am applying, there is some force of friction, okay, and this force of friction is called sliding friction. This is called sliding friction. While combing your hair, when you comb your hair, then also you receive some friction, okay, and that friction is called sliding friction, okay. When the ball is rolling on the ground, or when you are riding a bike, okay, then there is a force of friction between the your tire of the bike and the ground, and that force of friction is called rolling friction. So there are different types of friction, and this causes of friction, as we know, there is an interlocking of irregularity between two surfaces in contact is the main reason, okay. So smooth surface has minute irregularities and rough surface has more, so rough surface has more friction, okay. So this friction force is not desired in some cases. What are the cases in which friction force is not desired? Bearing, okay. In case of bearing, we don't require. In case of power screw, gear, flow of fluid in the pipe, propulsion of aircraft and missile, okay. So these are some cases in which we don't require or we don't need this force of friction, because here this force of friction will ultimately cause wear and heat generation, okay. And friction force is desired in some cases like brakes, clutches, belt drive, wedges, okay, and walking depends on the friction between the shoe and the ground. So these are some cases where the force of friction is desirable, okay. Now what are different types of friction? Friction is basically classified mainly on the basis of on two types, dry friction and fluid friction, okay. So this fluid friction is the motion of the fluid across a surface, okay, and the resistance that it receives while motion, okay, that fluid resistance is due to the friction. And in when you will study this in the fluid mechanics, this resistance is nothing but called viscosity. So viscosity is nothing but friction or the frictional resistance that it offers to the motion of the fluid is called viscosity in case of fluid mechanics. But if we talk about this in the case of solid mechanics or mechanics of rigid body, then it is called dry friction, or it is also called Coulomb friction, okay, and it occurs between two unlubricated or dry surface of two solids in the contact, okay. And this is basically classified into static friction, kinetic friction. Kinetic friction is further classified into rolling, sliding friction, okay. So friction are mainly of two types, static friction, dry friction, two types, static and dynamic or kinetic, and this kinetic friction is of two types, rolling and sliding type, okay. Now suppose there is a block which is kept on the ground, okay, which is kept on a surface, okay. Now suppose this block is and some force is applied on this block in this direction, okay. Now what you say, if you are applying some force on this block, will this block will start to move immediately? No, it will not. Why? Because we know that there is a minimum amount of force that we need to apply so that this block will resist this frictional force which is opposing this motion. As soon as this force which is applied, P is greater than the frictional force, this block will start to move. So we need to find this minimum force after which this block will start to move after resisting this force of friction. That minimum force is called limiting value of friction. Okay, and this limiting value of friction is nothing but the maximum value of friction, maximum value of frictional force which will oppose the motion. Okay, now there is another concept. This minimum value of limiting friction, will it be in the starting of the motion or before the motion? Which is the case in which this maximum value of friction will be there? As we know that this friction force will oppose the motion before starting of the motion. Okay, after starting the motion, the force which is applied will be more than the friction force. That means before movement, the force of friction is called the maximum value of friction is called the limiting friction, and that is also called as static friction. So static friction is the friction which when the body is at rest, okay, and the friction force which is applied when the body is not moving, okay, or is about to move, that maximum value of friction force is called limiting value of friction force. Okay, suppose that this is a diagram of force and the applied force and the frictional force. Okay, so as you can say that up to this level, this is a level up to which this body is not moving, okay, and the body is static or it is at rest. Okay, after this force, maximum value of frictional force, there is a decline in the value of frictional force, okay, and the body is start to move. Okay, so the friction is basically classified into two types: static friction and kinetic friction or dynamic. So static friction is the friction which comes into play when the object is not moving, okay, and dynamic friction or kinetic friction is the friction is when the object start to move, then the friction is called dynamic friction. So the value of frictional force in case of static friction is equal to mu into the normal reaction which is equal to R. Now why this is equal to normal reaction, we need to understand. So if we take the example of this block, when this, as we know that the motion is taking place only in this horizontal direction, in the vertical direction by the function equilibrium, net force in the vertical direction is equal to 0. That means the total reaction will be equal to the weight mg. Okay, now this reaction force R, this is equal to, this is a total reaction force in the y direction. Okay, so the force of friction will be equal to mu into this normal force or this reaction force, okay, that is opposing the weight of the body, okay, that is equal and opposite to the weight of the body. Okay, and since this is R is equal to N is equal to mg, okay, so we can say that this static friction is equal to mu s into mg, and the dynamic friction is also equal to K, kinetic friction is equal to mu k into mg or mu k into n. Okay, so this is the concept of limiting friction. Now there are different laws of friction, dry friction. The first law of dry friction is that the friction is independent of the magnitude of area in the contact. Okay, so friction is independent of the magnitude of area. The total friction force that can be developed is proportional to the normal force transmitted across the surface of contact. That means frictional force is proportional to the normal force, and when we remove this proportionality constant, then we received this n. This mu is called coefficient of friction, which is equal to frictional force over normal force. Okay, alright, now for this low velocity, the total amount of frictional force that can be developed is independent of the velocity. Okay, for low velocity the frictional force is independent of the velocity, and by second law we know that the force is directly proportional to the normal reaction frictional force, and this is equal to mu n. Okay, now if we see this example, suppose that this is the normal force and this is the frictional force. Okay, now the resultant of this normal force, suppose this is the resultant of this normal force which is making angle of theta here. Okay, Now this tan theta will be equal to the frictional force. If this is theta, this will be the perpendicular. Okay, this is theta, this is the perpendicular over hypotenuse. Okay, so perpendicular tan theta will be equal to mu. Okay, and this will be equal to F over N, where F is the frictional force, N is the normal force. Okay, so there is a term called angle of friction or angle of repose. Okay, and this is nothing but the angle between this angle between the frictional force and the normal force is called angle of repose. Okay, this is equal to tan theta and this is equal to mu, and this is also equal to frictional force over normal force. Okay, suppose this is a block which is kept on a horizontal surface. So in this case the angle of friction or angle of repose is equal to frictional force over normal force. Now suppose this block is kept on a vertical plane like this. Okay, so the mg will be acting around this center of gravity. This is the point of center of gravity where the weight of the body will be acting. Suppose this body is kept on a inclined plane making angle theta with the horizontal. Okay, so this angle will also be theta. Okay, now as this angle is theta, we can resolve this weight into two directions. In the x direction it will be equal to mg cos theta, and in this direction it will be equal to mg sin theta. Okay, now due to this movement, and this will be causing the movement of this block down the plane. Okay, and this moment will be resisted by a frictional force which will be equal to mu into n, normal reaction. Okay, so the angle which this block will make with this normal and with the frictional force, this angle will be equal to tan theta, and this will be equal to mu, and this will be equal to frictional force. Frictional force is equal to, now this is equal to mg of sin theta, and this will be equal to mg of cos theta. So if we balance it, we can say that mg of sin theta is equal to mu into n. Okay, in the x direction if the forces are balanced, so in that x direction mg sin theta is equal to frictional force. Okay, we have resolved this weight into two directions. Mg cos theta is the component in the x direction, and in the y direction is mg sin theta. So if it balance it, this will be mg sin theta will be equal to mu into n. Now in the y direction, if we apply balance equilibrium of forces, so it will be mg cos theta will be equal to n. Okay, so this n is equal to mg cos theta. Okay, so this will be mg sin theta will be equal to mu into mg cos theta. Okay, so mg get cancelled out, so that means sin theta over cos theta is equal to mu. That means tan theta is equal to mu. So mu, which is also called coefficient of friction, is equal to the tan of the theta, and theta is the angle between the normal force and the frictional force. Okay, so that means mu is equal to tan theta will be equal to frictional force over normal force. Okay, now there is a resistance, also a resistance called rolling resistance. So as I told you, static friction and dynamic friction are the two types of dry friction. Okay, dynamic or kinetic, and this is further classified into sliding and rolling friction or resistance. Okay, so sliding, as you know, that sliding friction is a friction which, when the two surfaces which are in contact are one surface sliding over the other, then it is called sliding friction. Okay, and the example of sliding friction is read when you comb your hair. Okay, or when you are writing on some board. Okay, this is sliding friction. You need to slide your pen across the board. This example of nothing but sliding friction. Rolling friction example, when the one of the surface is having some wheel or a roller. Okay, when two surfaces are in a contact are moving, and one of the surface is a wheel or a roller, or it is a rolling body, then the resistance which comes into play, or friction resistance, is called rolling resistance. Okay, for example, riding a bike, then there are friction between tire and the ground, and when you used to bowling, okay, bowling is a game in which you used to throw a ball and used to hit some obstacles, okay. So that is also example of a bowling is a game, and the example of bowling in a lane is also example of a rolling resistance, okay. Now we have understood the concept of the friction, what are different kinds of friction, okay. Now we'll be solving some numerical on this concept, okay. Suppose that there is a block, okay, there is a block which is kept on an inclined plane, and this block is having weight of 300 Newton, okay. And the question is given that 100 Newton of force act as shown on a 300 Newton block. So we have applied a force of 100 Newton on this 300 Newton block. The coefficient of friction between the block and the plane are mu s is given 0.25 and mu k is equal to 0.25, okay. So coefficient of static friction is given as 0.25 and kinetic friction is 0.2. You have to determine whether the block is in equilibrium, okay, and also you have to find the value of frictional force. Now, when this block will be in equilibrium, the question is that when this block will be in equilibrium. Block will be in equilibrium means when the block is not moving, when the forces are balanced in the x direction and also in the y direction, okay, and this can only be happen if this force which is applied here is equal to the frictional force. So we have to see what is the value of frictional force. Now friction force is also equal to static and dynamic kinetic friction are given to you. So firstly you have to apply the force balance equation. So this weight will be acting downwards 300, okay, and this is making angle of theta. Now this theta will be equal to, since this dimension is given to you, so this is equal to theta, so tan theta will be equal to, perpendicular is equal to 3 and this is 4, is equal to 3 by 4, okay, and sin theta will be equal to, from here will be equal to perpendicular 3 by 5, okay, and cos theta will be equal to 4 by 5, base over hypotenuse. So in this question theta is not directly given, but the dimension of this are given to you. From here you can easily find the value of theta in terms of these values, okay, and then in terms of this number or ratio, okay. Now this mg will have two components. In the x direction this will be mg of cos theta, okay, and in this direction, this is direction, in this direction, opposite direction, this will be mg of sin theta, okay, in this direction opposite to the force. Now if you apply a force balance, so in the x direction it will be summation of x is equal to 0, okay. So in this direction there is a force called 100 Newton, okay, and this is equal to frictional force plus mg of sin theta. So frictional force will be equal to 100 minus mg of sin theta, okay, this will be equal to mg is equal to 300, weight is already given to you 300 into sin theta. Now sin theta is equal to 3 by 5. So after solving it, this will be equal to 5, 6 are 30. This will be equal to 100 minus 148. This will be equal to 100 minus 6, 3 are 18, 180. So this will be equal to minus 80. Frictional force is equal to minus 80 Newton. Okay. Now why it is minus here? That means this sign of frictional forces that we have taken is not correct. This will be in this direction. Okay, opposite direction. And if it is in opposite direction, that means, as we know that frictional force is opposite to the direction of the applied load. That means this load is applied in this direction. Okay. Now, this frictional force is equal to minus 80 Newton, or we can say, if we take the magnitude, this is 80 Newton. Now you have to determine the value of whether block is in equilibrium, and for that you have to also determine the value of frictional force. Frictional force is equal to mu into n. Value of mu is given to you. This is 0.25, okay, and 0.20. You have to find the value of n, and that you can find by force balance in the y direction. Okay, so force balance in the y direction is summation of Fy is equal to 0. So in the y direction, mg cos theta, okay, it is given to mg cos theta, and this is equal to n. So N is equal to mg cos theta, mg is 300, 300 into 4 by 5, this will be equal to 5, 6 are 30, 240 Newton. Okay, so N is coming out to be 240 Newton. Now we have to find the value of static friction. Static friction is force is equal to mu into static, this is given to 0.5 into normal force. Okay, so this static friction will be equal to how much? 0.25 into 240. So this will come out to be 48 Newton. Okay, so coefficient of static friction, as you know, this is the maximum value of friction. Okay, or we can say this is the maximum value of resistance force with which the object can oppose the motion. Okay, and since this maximum value of friction force is less than the applied force is equal to 100 Newton. That means the object will be resisting the frictional force and this will move down the inclined plane. Okay, so that means this force will be block will move down the inclined plane because the force of applied force is greater than the frictional force or maximum value of frictional force. And also, if whether the block is in equilibrium, no, block will not be in equilibrium, because had it been in equilibrium, the applied force would have been equal to the frictional force. Since it is not equal to that, that means block is not in equilibrium, and the value of frictional force is equal to 80 Newton. Okay, so this is one of example of a frictional force, okay, or friction, and we'll be solving some more numericals when I will be covering some previous year GATE questions on the topic of friction. Okay, so this is all for today. In the next video lecture, we'll be studying about kinematics and dynamics of a plane body, and also concept of principle of virtual work. Okay, so this is all for today. Thanks for listening. Have a nice day. Thank you.